Okay, so this is the last section we're going to be dealing with. I'm going to give you two different parts of it. Let's deal with section 3.6, and here we're talking about graphing rational polynomials. Okay, so rationals are our ratios of two polynomials. So it would be some polynomial of x over some other polynomial of x. Okay, and you're going to learn to do these. You're going to have to graph without technology. This is basically ultimately what we've been at. This section, or these next two sections, we'll use everything we've talked about at some point or another. And this is basically, this unit is where I'm going to learn to separate those doing the work and understanding it from those copying from their neighbor, from your partner. And this guy's going to do it for me. At the end of this test, I'm going to know exactly who has been copying from other people and who has not. Okay, so let's talk about how we're going to do this. Here are our steps to graph. All right? Step one, factor numerator and denominator. Step two, find intercepts. X-intercepts are the zeros that we've been dealing very heavily with. Y-intercept is where x equals 0. Okay, so now that's the third step. That's the second step. Third step, we're going to need to find our asymptotes. And these are going to come in three flavors. Vertical, which are values which make the denominator 0. Horizontal, which is our end behavior. In other words, how it behaves as we go to plus or minus infinity. X goes to plus or minus infinity. And then the third one are slant. These only occur if the degree of the numerator is 1 greater, and it has to be exactly 1 greater than degree of denominator. And you'll find these, and I'll work an example of this. To find these, we're going to use synthetic division. Usually, you can also use long division. All right, so once we've got all our asymptotes, we need to find behavior around asymptotes, or near the asymptote, near your vertical asymptote. What you're going to do by using some test points. And then finally, we're going to sketch the graph using all our points. All right? So once we found it, now it has to go through the x and y intercepts. Asymptotes are values it approaches but doesn't get to. So here are our basic steps. And let's work through some examples here. So my first example, my polynomial is 3x minus 10 over x squared minus 4x plus 4. Step 1 is to factor. Numerator is already factored. This guy right here is going to be x minus 2 squared. So we end up with 3x minus 10 over x minus 2 squared. So next we need to find our x intercepts, which are values which make the numerator equal to 0. We don't want to set the denominator equal to 0. That's a vertical asymptote. We just want to find x-intercepts where this equal to 0. So we take our numerator and we solve it. 4x is 10/3 or about 3 1/3. Okay, now we need to find our y-intercept, which is where x equals 0. So I plug x equals 0 into both the top and the bottom. We'll have 3 times 0 minus 10 over 0 minus 2 squared, which is going to give me a negative 10 over 4, or negative 2.5. So there are my x and my y intercepts. Remember, it has to go through, the graph has to go through these points right here. And x-intercept, remember, is where it crosses the x-axis, and this is where it crosses the y-axis. All right. So we're done there. The next thing we need to do then is find our vertical asymptotes. Vertical asymptotes is what makes the denominator equal to 0. Okay. So when we came out there, what I found was, if you remember, our original polynomial was 3x minus 10 over x minus 2 squared, and it's factored. So I want to find out what makes this equal to 0. You can see why we factored this. So I need x minus 2 squared to make what this is 0. So my vertical asymptote is going to occur when x equals 2. All right, now we take a look at our horizontal asymptote. All right, remember we talked about horizontal asymptote in the original. This is where you might want to go back to the original itself. You've been paying attention. You notice it's governed by just the highest order terms, because what we're interested in as x goes to plus and minus infinity as x gets big. So what I do is I just take my highest order terms, 3x over x squared, which will come out to 3 over x. So as x goes to infinity, this will go to 0, okay? And as x goes to negative infinity, this also will go to 0. So here's my horizontal asymptote. If you remember from Algebra 2, we had talked about the fact that when the denominator was larger than the order of the denominator, was larger than the order of the numerator, that your horizontal asymptote was 0, and that's what we've got. So now we've got our end behavior. So the third one we got to look for is our slant. All right, and it only occurs if the degree of the numerator is 1 bigger than the degree of the denominator. We have no slant because degree of numerator is not 1 larger than degree of the denominator. So we're done there. All right, so the next thing we need to do then is to actually come in and we need to start worrying with the behavior around vertical asymptote. Okay, so at this point, I can actually start plotting my graph already, or get some things on there. So we know that our x-intercept was 10/3. Or 3 1/3. So I know it's going to have to go through this point about there. And my y-intercept was negative 2.5. So it's going to have to go through this point also. All right, so the next thing I want to do then is I've got that. Let's draw my vertical asymptote. It occurs when x is 2. And this is my horizontal asymptote. The x-axis is, or y is 0. Okay, so to figure out what it's going to do, first thing I'm going to do is pick a test point just a little bit to the left of 2. So I'm going to try 1.9. Now, you don't actually have to know what the value is. You just have to know how it behaves. And so I'm going to come in, I'm going to plug it back in up here. So I'm going to have 3 times 1.9 minus 10 over 1.9 minus 2 squared. Okay, this is going to be some number. It's going to be somewhere around 5 or 6, but it's going to be less than 10, which means that the top is going to be negative. Anytime I take any number and square it, it's going to be a positive. And so the resultant one is negative, which means it goes to negative infinity or it goes down. So what I know is my graph, if I put it in here, is going to go down over here. Okay, so now we find a point on the other side over here that's a little bit off, like 2.1. I'm going to have 3 times 2.1 minus 10 over 2.1 minus 2 squared. Again, my denominator is always going to be positive because I'm squaring it. This is going to be 6, still going to be negative. So this also goes down, or it goes to negative infinity. So now I'm going to go to negative infinity over here also. So I've got part of it drawn already. All right, now at this point, we're about ready to deal with this thing. What I know is I'm going to go to negative infinity here. I'm going to have to come up, and I've got to go through my y-intercept. So I draw that, and I know it's going to approach this value here. So it's going to come up something like this. Okay, the other thing I know is over here, I'm coming up, but it's going to have to go through my x-intercept. It'll probably come up, but it's going to have to come back down, and it's also going to approach 0. And there's our graph. This is how we do this. So let me work one more example for you. And this one is going to be x squared plus 2 over x minus 1 is going to be our function. All right, so step 1 is to factor. We're already factored on this one. So step 2, my x-intercepts, which is what makes the numerator 0. So I have an x squared plus 2 equals 0. X squared equals negative 2. X equals I plus or minus the square root of 2. It's imaginary, so I've got no x-intercept. All right, y-intercept, I just plug in 0. So I'm going to have 0 plus 2 over 0 minus 1, which is a negative 2. So there is my y-intercept. Okay, and we have 2 points at this point. So number 3, we've got to find our vertical. All right, the vertical is what makes the denominator 0, or my vertical is going to occur at x equals 1. So there's my vertical asymptote. Horizontal. Let's take a look at this. We're just interested in the big ones. X squared over x, which is x. So what this means then, as x goes to infinity, y is going to go to infinity. This also means this thing's going to act like a line with a positive slope. So as x goes to negative infinity, y is also going to go to negative infinity. So we've got those. And we got one more thing we need to worry with, which is the slant. And we do have a slant in this case, because the order of my numerator is exactly one more than my denominator. And so we find this using synthetic division. So I take the 0 of my denominator, which is 1, and then I'd copy my coefficients, which are 1, 0, 2. We do our synthetic. Bring down the 1. I'm going as 1. You add them. 1. 1 times 1 is 1. We get a remainder of 3. This right here gives me the coefficients of it. So my slant asymptote is going to be equal to x plus 1. And that's the equation of my slant asymptote. Okay, so now at this point we can come in and actually, and probably should, start graphing some of this data. So let's do this. So my x-intercept, we had none. My y-intercept is at -2. All right. This tells, let's get our, we've got a vertical asymptote at x equals to -2. X equals to 2. In behavior, we know we're going to be going up out here and down out here from here. So the next thing I'm going to do then is to actually graph my line. And x plus 1, so that's a y-intercept. There's my slant asymptote. Now what I know is that as I come down here, this thing's going to come over, but it's not actually going to cross my slant asymptote. It's just going to get close to it. Okay. So now the last thing we need to do then is to deal with behavior around this thing. So let's come over slightly to the left of 2, and let's deal with a test point of 1.9. So I put that into my original, which will be 1.9 plus 2 squared over 1.9 minus 1. Again, I don't care what the number is, but that's going to be a positive over positive, which means it's going to go up. All right? So what that tells me is that up here, on this side, I know it's going to go up. I've got no x-intercept, so this thing is going to look like this. So we'll do it. This thing is going to look like this. It's going to approach it, it won't draw it. There we go. It's going to go out here and up here. All right, now, and I know I've got no x-intercepts. I do know that I go to infinity, and sure enough, that's what I'm doing. On this one, we know we were going, 1.9. Oops. I picked a point over here. I got the wrong one. And I got the wrong thing. It said x equals 2. So this should be 0.9. X equals 1 is my asymptote, not x equals 2. So my vertical asymptote's over here. So let's pick 0.9. And again, you plug it back in, so I'm going to have 0.9 squared plus 2, which is going to be a positive. And then I will have 0.9 minus 1, which is a negative. So what I know is on this side, it's going to go down. All right? So I'm going to go down here. Now I know I've got to come up. I've got to go through this point, and I come back around, and I approach but never get to this slant asymptote. So now I'm going to pick a point over here, which is 1.1. And again, we plug it in. I'm going to have 1.1 squared plus 2, which will be a positive. Then I'll have 1.1 minus 1, which is a positive. So positive or positive, positive means it goes up. And this thing looks like that. And that is how you graph these things.